Hello friends, Mr. Burrell here. We're starting a new unit. We're moving into Unit 4. This unit is all going to be about dilations and similar triangles. So in Unit 3 we talked about like parallel lines and some of the relationships between different angles and different things we could do with that. We're going to kind of extend that, continue talking about like angles and shapes and kind of the geometry side of mathematics. We're going to extend that and keep talking about it in Unit 4 with dilations and similar triangles. Starting off with dilations. We're going to talk about what I mean when I say the word dilation, what it means in a geometry and in a mathematical sense, and how it can be helpful to us and how we can work with that. So by the end of the lesson today, these are the things that I hope that you're able to do. I want you to be able to state whether a dilation is a reduction or enlargement based on its scale factor or graph. Find a scale factor of a dilation from the graph. Find the scale factor of a dilation given a point from before and after the dilation. And know that to find the dilated image of a point, I multiplied the x and y coordinates of that point by the scale factor. So those are the things that I hope that you're able to do by the end of this video. And if some of those terms don't make sense, that's okay, because we haven't talked about them yet. So when I say the word dilate, what does that mean? What comes to mind? So have you ever been to the eye doctor and they put that stuff in your eyeball that makes your pupils get all big in order that they can get in there and work on stuff and see what's going on? That's when they go in there, that's called a dilation solution because it makes your pupil bigger or dilated more. So when you're thinking of your eyes, the pupil either is constricted or it gets smaller, or it's dilated, it gets bigger in order to let smaller or larger amounts of light into your eye. So when it's really light in a room, your pupil will get really small. If it's really dark, your pupil will get really big. It'll dilate bigger in order to let as much light in as possible. So dilation is getting bigger or getting smaller, specifically when it's talking about the pupil in your eye. So again, dilation means making larger or smaller. It's the same thing in a math sense. Dilation means taking an image or something and making it either bigger or smaller. Specifically, when I'm talking about dilations, an enlargement is a dilation that makes an image larger or bigger, and a reduction is a dilation that makes an image smaller or reduced. Enlargement, reduction, larger, smaller. See that? Another term that we're going to talk about in this section is a scale factor. A scale factor determines how much larger or smaller an image is dilated. Okay, so a scale factor is going to help me determine how much larger or smaller my image is dilated. And then to explain what a center of dilation is, I'm going to go ahead and draw a little picture. So say I have this point over here on my screen, and I have this triangle. See that? So let me change colors. I'm going to go ahead and draw a dotted line from this point to this other point on the tip of this triangle. Okay. So say I took this length right here and I doubled it. So I did the same distance on the other side. See that? I'm going to go ahead and put a point right here. I'm going to do the same thing with this point right here. If I were to take this distance and extend it twice as big, that point would be right here. If I were to take this distance, whoop, whoop, and make it twice as big, so extend it all the way over, I don't know, right about there, give or take, put a point right there. I'm going to go ahead and connect these dots. Take notice to what is happening here. So I've just taken each of the distances from this point to each of these points on the triangle, and I've doubled them. So notice what happened to this new triangle that I just created. Notice that it is double the size. So if you've ever taken a flashlight and you've shown it from one point and you notice that right here all the light is concentrated at one point and then it kind of spans outward, you kind of see that same effect here if I'm starting right here and I kind of expand outwards to each of these different points, kind of having that same effect. So this original triangle, this red triangle, I would say that it has been dilated by a scale factor of 2. Notice that this blue triangle is twice as big. It's been dilated by a scale factor of 2. And when I backtrack through all of these points back to this point right here, the point where I started, that point is called the center of dilation, kind of the point where my dilation starts. So I could go like 3 times as big, I could go half as big, all along these same dotted lines, and I could form a bunch of different dilations. So this point right here is called the center of dilation. Okay, so let's take a look at this. So a dilation, again, as I mentioned before, a dilation, let me change my color, is an enlargement if the scale factor, whatever the scale factor n, is greater than 1. And the dilation is a reduction if the scale factor n is between 0 and 1. So for example, here on this picture right here, I have this one right here. I have this parallelogram ABCD, and this side length right here is 2. And it says the scale factor is 2, meaning that each of these distances on the red parallelogram are double or twice the corresponding distances on the blue parallelogram. So since this side length right here on the small parallelogram was 2, on the bigger parallelogram, when I enlarge it by a scale factor of 2, so it's twice as big, this side length ends up being 4. We'll stay on this picture right here. I have this big trapezoid. That's what this is, this big trapezoid, and this side length right here is 8. And it says the center of dilation is this point right here. So around this center point, it says the scale factor is 1/4, which means all of these distances, like this distance here and this distance here, this distance here and this distance here, are going to be reduced by a factor of 1/4, or it's going to be 1/4 as big. So if this side right here was 8, the corresponding side on the reduced, the dilated reduced image would be 1/4 of that, or in this case, 2. Okay, so let's take a look here. So I have 4 scale factors, k equals, k equals, k equals, k equals. I have 4 scale factors, and I want us to determine whether these dilations with these scale factors are a reduction or an enlargement. So if the scale factor was 3, would that be a reduction or an enlargement? That would be an enlargement. That would be an enlargement because I'm making my image 3 times as big as it currently is. So that would be making it bigger. If I had a scale factor of 1/3, would that be a reduction or enlargement? That would be a reduction because I'm making my image 1/3 of what it was before. 1/3 is smaller. If I take my whole and I take 1/3 of it, that's going to be smaller. What about the scale factor 3/2 or 3/2? Is that an enlargement or a reduction? Our brain is tempted to say that's a reduction because I'm like, oh, look, 1/3 was a fraction, 3/2 is a fraction, it must be a reduction. But 3/2 note, if I like type that in my calculator, if I figure that out, 3/2 is actually like 1.5, 1.5, which is bigger than 1. So my image would be 1.5 times the size, which would be an enlargement. I'm going to abbreviate this, enlargement. And then this last scale factor is 0.67, which again, even though it's a decimal, kind of same process follows since it's between 0 and 1, that's going to be a reduction. Okay, that's going to be a reduction. Okay, so that's going to be the first part of our homework assignment, determining whether a scale factor gives me a reduction or an enlargement. Okay, so now I have some points. Say I had a coordinate graph and I plotted some of these points. I should draw this graph over here. I have some points. This point is 1, 1. This point is 2, 3. I have some points on a graph here, and I want to dilate these points by the scale factor over here. So I'm going to dilate these points according to this scale factor. And with all these problems that we see with graphs, when we start looking at graphs, we're going to assume the center of dilation is at 0, 0, at the origin. Unless I tell you differently, we're going to assume the scale factor, or the center of dilation, is at the origin, 0, 0. So if that's the case, if I wanted to dilate these points by a scale factor of 3, let me change colors again, I'm going to multiply each of those coordinates by 3. So if I have the coordinate 1, 1, 1 times 3 is 3. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. So let me extend my graph a little bit. 3, 4, 5, 6, 7, 8, 9. 4, 5, 6, 7, 8, 9. So my dilated points would now be at 3, 3, and 3, 4, 5, 6, 9. And notice if I were to draw a straight dotted line, I would passing through those points, I'd fall exactly on top of those dilated points. So this line right here and this line right here, this line should be 3 times as long as this line, which if we went and measured it, it would be. So what if I had something like this, the points 3, 6, and 3, 9, and I wanted to reduce that image by a scale factor of 1/3? Well, then I would multiply all of these coordinates by 1/3, or in other words, divide by 3. So 3 times 1/3, or 3 divided by 3 is 1. 6 divided by 3 is 2. 3 divided by 3 is 1. 9 divided by 3 is 3. So the new points of my image would be 1, 2, and 1, 3. 1 in the x direction, 2 in the y direction, 1 in the x direction, 3 in the y direction. What if I had the point 2, 4, and I wanted to enlarge it by a scale factor of 3/2? Well, I would multiply each of those coordinates by 1.5. You can use your calculator, you can use your brain, whatever you want to. 2 times 1.5 would be 3. 4 times 1.5 would be 6. So my new coordinates of that point would be 3, 6. And I go on and I go on. If I wanted to reduce this, the coordinates 1, 1 by the scale factor 0.67, I'd multiply both of those coordinates by 0.67. 1 times 0.67 is 0.67. 0.67, so my points would be 0.67, 0.67 in the x direction and in the y direction. Okay, so again, for our purposes, the center of dilation will always be at the origin. So to dilate a coordinate point like 3, 4, we simply multiply the x and y coordinates by the scale factor. Then to find the scale factor from a dilated image, we divide the coordinates of the dilated image by the coordinates of the original image. So let me show you an example. So this says determine whether each dilation is a reduction or an enlargement, then find its scale factor. So I have this, it says from orange to blue. So on my screen we have parallelogram A, B, or sorry, this is a rectangle probably, A, B, C, D, and then I dilate that image to give me A prime, B prime, C prime, D prime. That's how I would say that. So first of all, is this a reduction or is this an enlargement? Well, I'm going from orange to blue. I'm getting bigger. So this is going to be an enlargement. So right off the bat, I know that my scale factor K, is going to be bigger than 1. So it's either going to be like twice as big, or 3 times as big, as 4 times, or 4 times as big. Okay, so I'm going to pick any point on this graph. I'm going to go ahead and pick point B, this one right here, and this one right here. So I'm going to look at my dilated image. This point right here is 4, 4. This point right here is 1, 1. So I'm going to take these coordinates right here, 4 and 4, and divide by these coordinates right here, 1 and 1. That will give me my scale factor. That will tell me how much bigger my dilated image is in comparison to my original. Well, 4 divided by 1 is 4. So my scale factor is 4. Okay? Let's look at the green one. So first of all, going from green, PQRS, to purple, this one down here, P prime, Q prime, R, P prime, Q prime, R prime, S prime, am I getting bigger or smaller? I'm getting smaller. So this is a reduction. So I know right off the bat that my scale factor K is going to be some like number or fraction or decimal between 0 and 1. Okay, so I'm going to take a point, any point, on my dilated image, say this one. This point is at 2, 2. And the corresponding point over here would be 8, 8. So this point is 8, 8. So let's take my dilated image, this one, 2 and 2, and divide by my original image, 8 and 8. What's 2 divided by 8? Well, if I write that as a reduced fraction, it's 1/4, or if you write it as a decimal, it's 0.25, which I would take either of them. So my scale factor is 1/4. This purple image is 1/4 the size of my green image. What if you had accidentally gone in here and said, okay, well, let's take 8 divided by 2 and 8 divided by 2, and you got a scale factor of 4. Well, right off the bat, you can say, no. At the beginning, before I even started this math process, I determined that this was going to be a reduction. And a reduction has a scale factor that's between 0 and 1. 4 is not between 0 and 1, so that's got to be wrong. You have to kind of reanalyze yourself. Remember, a dilation that has an enlargement will have a scale factor bigger than 1. A dilation that's a reduction will have a scale factor between 0 and 1. Okay, so we're going to do 1 or 2 of these. This says, draw the shape after a dilation with the given scale factor. Let me move my face out a second for a minute. So I'm giving you a shape, and I want you to draw what the dilation would look like with the given scale factor. So I'm going to write each of these coordinates up here. I'm just going to do 2 of these quickly together. So this point is 8, 8. This point right here is 8, 0. This point right here is -4, -4. This point right here is -4, +4. So if I want to dilate this image by a scale factor of 1/2, I'm going to multiply each of these coordinates by 1/2, or I'm going to divide them by 2. So 8 divided by 2 and 8 divided by 2 is going to give me 4, 4. So that's this point, R prime. 8 and 0, 8 divided by 2 is 4, 0 divided by 2 is 0. So my new point S prime is going to be right here. Over here I have -4, -4. Take both of those divided by 2. I'm going to have -2, -2. That's P prime. And then -4, +4. If I divide both of those by 2, I'm going to get -2, +2. So that's Q prime. So right there, if I were to draw my little image, that would be my dilated image by a scale factor of 1/2. Okay? Let's do this one right here. If I have a rectangle ABCD with a scale factor of 2, I'm going to take each of these points, I'm going to multiply them by 2. So like here I have 1, -1. This point right here is -1, -1. This point right here is 1, -4. This point right here is -1, -4. You see that okay? So I'm going to multiply each of those points by 2. So 1, -1, that's going to turn into 2, -2. -1, -1, that's going to turn into -2, -2. 1, -4 is going to turn into 2, -8. And -1, -4 is going to turn into -2, -8. See that? So now if I connect the dots, notice that I'm going to have this rectangle right here. This is A prime, B prime, C prime, and D prime. And let me change colors one more time. Note again, if I were to write a dotted line through these points here from the origin, notice that I would line up exactly on the points on my dilated image. Okay? Let me give you one more quick example of dilations. This is like an example of a real-world problem you would see. So say the height of your document on your computer screen is 20.4 centimeters, and when you change the zoom setting on your screen from 100% to 25%, the new image of your document is a dilation of the previous image with a scale factor of 0.25. So like when you do that zoom setting, if you're typing something on your computer and you change like the zoom down in the corner from 100% down to 25% or something like that, that would represent a dilation of your document from being bigger to getting smaller. So if I were to take this height, the height of this document being 20.4 centimeters, and I dilate by a scale factor of 0.25, I'm going to go ahead and multiply 20.4 times 0.25, or by 1/4, a quarter, 25% of the size. So 20.4 times 0.25, that's going to give me 5.1 centimeters. So now, instead of being like 20.5 centimeters tall on your screen, the new dilated image is going to be 5 centimeters tall or something like that, 1/4 of the size. That's a dilation. Okay. That's all I've got for you today. Hopefully at the end of this lesson, the end of this video, you feel a little bit more comfortable with some of these concepts. Please don't hesitate to reach out to me if you have any questions, whatsoever, please let me know. And I hope that you enjoyed that as much as I did.